and in some cases can actually knock an entire country off the web.
Hey everyone, Yaniv Hoffman here, back with another video and back with a very distinguished guest, Occupy the Web. Welcome.
Thank you, Yaniv. It's always an honor to be on your show.
Thank you very much, Occupy the Web. And if you are not familiar with Occupy the Web, we did a series of videos, mainly on hacking. You can check it out. I will put it on the screen as I speak. In addition, Occupy the Web is an author of some of exceptional books, Linux Basic for hackers, Getting Started, Becoming a Master Hacker, and the latest and recent book, Network Basic for Hackers, which completes the golden triangle, as I say, for the foundation of hacking. And if you watch some of the recent videos that Occupy the Web and I did, one of them was on distribute denial of service, DDoS attacks. And today we also want to speak about DDoS attack, maybe focus on one specific, which is called the HTTP rapid reset attack, which exploit vulnerability in the HTTP 2 protocol, which is widely used to improve web performance and security. And the attack invades actually, or involved the malicious use of a reset stream, which can cause resource exhaustion on the server, leading to a denial of service. So Occupy the Web will take us through it. We'll speak about DDoS attacks. We'll speak about the protocol vulnerabilities, how it works, maybe even see some pickup of that. And with that said, Occupy the Web. The show is yours.
Thank you, Yaniv. First of all, I want to emphasize to your viewers the importance of DDoS attacks in the cybersecurity realm. DDoS attacks oftentimes are not given enough attention, both from the attacker and from the defender's perspective, red team, blue team, right? Mm-hmm. But DOS attacks, or DDoS, there are such things. Some people, think there's only DDoS, but there are such things as DOS attacks where you can have a single machine attack a single server and knock it out. That's a DOS attack. Right. DDoS is when you have multiple machines. But the importance of DDoS is underestimated because it's possible that a DDoS attack or a DOS attack can basically knock somebody off, a company, a person off the web. All right, it can knock possibly an entire industry off the web. Of course, if you don't have access to the web, then you certainly can't do your e-commerce. You can't generally communicate, and in some cases can actually knock an entire country off the web when in terms of cyber war. And we've seen that in recent years, both perpetrated by Russia and their various attack groups and against Russia in the Ukraine-Russia war. So I think it's underestimated, and I think that one of the things I'd like to do in our series of talking is to emphasize how important this is. And so one of the new attacks that has come out in recent months, came out in the fall, it's called the rapid reset attack. And it's an attack against HTTP 2. All right. So most of the servers out there are running HTTP 1.1, right? There is an HTTP 2, right? That basically tries to streamline some of the communication between the server and the client. And so what we can do, I'm going to just kind of show a little bit of what came out from Google. This is information that came out from Google. And Google and Cloudflare were one of the first to detect, AWS as well, detect this attack and then publish information on it. All right. So here's just showing us an HTTP 1.1 attack. One of the key differences between HTTP 1.1 and HTTP 2 is that HTTP 2 allows for these streams that can send many, many requests simultaneously. Right. So here you see at HTTP 1, we send a request and we get a response. They're serial. All right. In an HTTP 2 attack, or just HTTP 2 in general, you can send multiple requests. Right. And oftentimes, to protect against a HTTP 2 attack, the server has a limitation of how many connections it can actually take, right? Like maybe 100, right?
Right.
But what the HTTP2 rapid reset attack does is that it sends a reset right after the request. And so when these resets are set out, the request is not counted against the limit number of how many requests. So we have a limit of 100. But those would only be requests that have been opened, okay, or are half opened. If there's a reset sent with it, then it's not counted against this limit. In that case, you can actually send out millions and millions and millions of requests. Right? And this is what has been seen by a number of different institutions who are hosting web servers, AWS, Cloudflare, Google, what have you. And it started up in the fall of last year. I think it was like September, October of last year. We began to see it. The attackers were able to send out so many requests that it set records. Let's go up here and see. There's actually 398 million requests per second. Right, so it set a new record. And basically, if we can sum this up, what it does is basically allow the attacker, the client, to send almost unlimited number of requests to the server and overwhelm the server with all these requests.
The uniqueness here, the traditional DDoS attack, DOS, or you mentioned it properly, DOS or DDoS attacks is bandwidth wise, its focus, it's a layer 4, which means either bit per second or packet per second. And here it's moved to the layer 7. That's the uniqueness, and exhausting the server from the RPS side. And while a normal website or application sometimes can handle maybe 5K, 10K requests per second, here we are speaking about 400 million.
400 million. It's amazing. Yeah. And basically, let's go take a look at CVE. Let me go ahead and just put that up on the screen here. We'll take a look at it. All right. Here's the CVE. It's 2023-44487, and the HTTP protocol allows a denial of service, server resource consumption, because request cancellation can reset many streams quickly, as exploited in the wild from August to October of 2023. So this is pretty new. This was just updated a few days ago. All right. There's lots of references here about what can be done. About 1/3 of the servers in the world, or the top 10 million servers in the world, use HTTP2. So that means about 1/3 are vulnerable to this attack. Right? Not all of them are, but about 1/3. So one of the things I'd like to do is to kind of talk a little bit, okay, about what's happening with this particular attack, and we can look at let's look at a PCAP of here's the PCAP. And this actually comes from Cloudflare, this PCAP, so you can get it on Cloudflare's site. All right, those of you who aren't familiar with Wireshark, you should get familiar with Wireshark. It's an essential tool of doing any type of cybersecurity analysis. If you're an attacker or a defender, you want to be familiar with this particular tool. So what we have here is just a captured PCAP of the rapid reset attack. You can see the attack begins right here. Right? You can see it starts with HTTP2 on packet 14. So we can click on packet 14. And then if we go up to statistics and we can go to HTTP2, we can get a little image of what's going on here, the count and the type and the window update and the settings and the reset stream, the headers, okay, and the data. Now, if we go ahead and let me click away from this, right, and we go over here to this is packet 14, and we take a look right here at the HTTP2 protocol, you'll see right here that the server, okay, has communicated that the maximum concurrent streams is 100. So they've got a limit set on how many streams that the server will accept, right? Now, if we go on to packet 15 here, and then we can begin to see, and we begin to see that we get these one reset, okay? And then we get a header and then a reset, another reset. And if we keep on scrolling down, we'll see that there's like, I think there's like 1,000 of these. All right. So what's happening is that each one of these streams that is followed by a reset isn't counted against the maximum number. And so the attacker can basically send just about as any number of streams to the server and then cause resource exhaustion, or the system basically is unable to take any more connections. And so this is a good example of it here. I'm hoping that you can see that we have the header sent here, and then each time after the header is sent, we get a reset. Now, those of you who are familiar with the reset in TCP, you know that reset, the RST flag set on the TCP connection, basically is a communication back to the client that, you know, that particular port or IP address is not usable. Something very similar happens in the HTTP2 is that this goes ahead, when the client sends this, it says, okay, I want to reset or start over on the stream. And as a result, they come out rapidly right after the request. The limit that the server has of maximum number of streams never gets counted. Each one of these streams comes out, the reset comes right after it, and therefore it's not counted against the limitation.
Yes,
so
the TCP connection is still open.
TCP is still open, right?
Yes, and by the way, in a typical HTTP2 server implementation, the server will still have to do a lot of work to cancel the request. Needs to allocate new stream and data structure. You need to parse the query, do header decompression, mapping of the URL to a resource. So it's a lot of work, while the client has no cost, right? As you showed, it just send the request and then immediately reset it.
Exactly. So the client is doing very little work. It's just sending out requests and then reset, requests and reset. And the server is doing all this work that you're detailing here. And that's what creates the resource exhaustion, or the DOS of the server, is that it has to do all this work for each one of these streams that's being opened up. So we can see that happening in these packets on packets 15 and 16. If we go through here, I think there's like almost 1,000. Oh, here it is, a stream identifier, 1,051, right? So this is all in this one packet, right? 1,051s, and there's then a request and a reset. So the server has identified in the very first packet right here. Let's go back here. And it says, here's the maximum number of streams right there, 100, right? But the client is able to get past that limit by simply sending an instantaneous reset after the request for the stream. And then the server is using up all its resources dealing with these requests. And because the reset comes immediately after the stream request, then it doesn't get counted against the limit of the server. So this is a ingenious, I think, a type of attack, in that it's basically using a feature, right, a feature of HTTP2 to exhaust the server. And of course, well, you know, we talked about how many packets we can get through this type of attack. The primary hosting companies now have put out some mitigation strategies, and for the most part, the mitigation strategies are one, to go ahead and disable HTTP2 in some cases, or or two, to use a service like Radware, like Cloudflare, and others to be able to detect these types of attacks and stop it. Cloudflare says that they've now been able to stop all of these attacks, but not all servers are being protected from this type of attack. And so that kind of brings me to the next thing I wanted to talk about, is like, how can I go and test to see whether or not my server is vulnerable to this type of attack, right? And so there is a proof of concept that came out just recently, I think in January, so it's pretty new.
Yeah.
And it's you can get it right here from a GitHub site called SecEngJef, all right? And he's gone ahead and created a proof of concept to test your server. It's all written in the Go language. Some people ask me, like, well, are all attack tools or all cybersecurity tools written in Python? And I have to answer them, well, not all of them, but most of them are. But we are beginning to see more and more written in the Go language, right? And so that's one of the things that we're, you know, at Hackers Arise, we're beginning to offer now, beginning in 2025, a Go language class for people who want to be able to develop in the Go language. So you can go ahead and download this client, right? And then go ahead and run it against your server. Make sure you have permission. Make sure that everybody knows that you're going to do it. Make sure it's okay with your hosting company, because it can wreak havoc on your website and the hosting company. And it can send out a vast number of requests with the reset and test to see whether or not your system is actually vulnerable to this type of attack. Let's see, I'm just going to kind of give you the basics of how to run this attack. I'm not going to run it because I don't I don't want to be able to knock out anybody's server, right?
Don't do illegal things here. It's everything for education and ethical.
Yeah, right. This is all for educational purposes. This isn't for anything malicious. The whole idea here is that if you are in a position where you're trying to protect the system, all right?
Yeah,
you want to go ahead and test to see whether or not it actually is vulnerable to this attack. So first thing you're going to do is go ahead and change into the proper directory. It's called the rapid reset client. All right, and then we move into there, and then we just got to go sudo, okay, and then rapid reset client. All right, that's the binary, and then you have to tell it how many requests you want to send out. Okay, so you say requests, say let's make it 20. All right, and then you tell it what the URL, okay, that you want to go ahead and test it against. Okay, HTTP, let's go Yanni. Do you have a website called Yanni Hoffman, by the way? You do?
And you can try.
Oh, no, that I'm not going to put it up there. If you have a website, I was making up. We'll just call it test. I call it. We don't want people using this against your website.
Testwebsite.com, definitely.
Testwebsite.com. That's what we're doing, right? I thought about using ours as
Guys,
a test.
do not test on my website, of course.
Yeah, I thought about using our
Only a
website, but I
blog.
thought everybody's going to be then sending it out against our website.
It's
So
true.
I decided against using that as an example. Even though I have obviously have permission, but I don't want to tempt other people. And then, so basically, number of requests, the website you want to go, the wait time in milliseconds, okay, between each invocation of the requests. All right. So let's go. Let's go 50 milliseconds. Okay.
Yeah.
And then the delay, if you want a delay built in there. All right. And then the concurrency. And we can set it at, say, 10 to get the maximum, the maximum number of packets, maximum number of concurrent workers, okay, sending these packets out. If you don't put in the concurrency, it defaults to 0. The delay defaults to 0. The wait time defaults to 0. And the request defaults to 5. So we've got something that's pretty aggressive here. And you can go ahead and run this against your website. If I go ahead and run it now, there's no testwebsite.com, so it's not going to do anything. But this is something you want to go ahead, test to see whether your site, like I said, about 1/3 of all the web servers in the world have HTTP2 enabled.
Right.
And then you're testing to see if your website has HTTP2 enabled, then you're testing to see whether or not you have proper protections against this. This is an excellent tool for going ahead and testing to see whether or not you can. Somebody could possibly go ahead and DDoS your site. Now, there's a number of mitigations that are out there.
GitHub became a huge repository for such tools. You don't need, in the past, you needed maybe to go to the dark web to find such,
yes.
But everything now is in the public in some way.
Yeah, exactly. So here's a number of ways to, first of all, to test whether HTTP2 is enabled, right? So you can use OpenSSL or Nmap or curl, all right? And then there's a vulnerability scanning tool that's available as well. And of course, you can go ahead and use this proof of concept, right? Against, as long as it's legal, as long as it's your own website and you have permission from all the proper people. There's some advisories of how to go ahead and protect against it. Okay, so here's Apache Tomcats. They fixed it in 8.5. Improvement to the HTTP2 overhead protection.
I think Occupy the Web, there are multiple forms, to mitigate it. But mostly you need to center around tracking the connection statistics using various signals and business logic to determine, how useful each connection is. For example, if a connection has more than 100 requests, as you said, with more than 50% of the given request canceled, it could be a candidate for mitigation response, right?
Here's the recommendations from Microsoft on their IIS server. And basically what they're saying is to go ahead and disable HTTP2, right? So it says this is one of their workarounds right here. So using the registry to go ahead and open up the HKLM system control current control set services HTTP parameters. Right. All right, and you can see here there's a D word there that's enable HTTP2 TLS. Okay, and just set the 0 to 1. Okay, and that's going to go ahead and disable HTTP2 on IIS.
But this is a band-aid, if you...
It's a workaround, exactly. Yes. It's a band-aid, right? It doesn't really fix the problem. No. It basically just works around it. But I've seen, looking at some of the other companies, that are out there, like NGINX and others, are offering similar band-aids in that they are basically saying, just disable HTTP2, right? So that's one of the things that can be done, and that's what many of the companies are actually recommending. Now, having a DDoS protection, right, is another solution, right?
Right.
It's a way to keep this type of attack from hitting your server. But if you don't have that, then you probably your simplest method is simply to go in and disable disable HTTP2, right?
Yeah.
And then your system isn't going to be vulnerable to this type of attack. So lots of different ways of doing it. You know, if it's a large company and they have the budget for DDoS protection by Radware or Cloudflare or others, then that's probably the best approach. If you don't, and your system is vulnerable, then you're probably best off simply disabling HTTP2. Right?
True, and it shows that first, these attacks, as you showed, can have a significant impact on service of any scale. You know, last year in June, Microsoft Azure itself was attacked by a DDoS attack, layer 7, based on what they said. Again, multi-million requests per second and went down. It wasn't exactly the reset attack, but it shows you these magnitudes of requests, because usually the bandwidth or the layer 4 DDoS attacks were the most significant one in the past, which exhausting, you know, utilizing the network, exhausting the servers, and application was always more of a low and slow, right?
Well, the reason that I really want to do more of these types of DDoS attacks is just because I think that they're going to become increasingly important. And I think that your viewers need to become familiar with the various strategies of both doing the attacks and protecting against the attacks,
right?
Especially in a world now where we have millions and millions of IoT devices that can be used in this type of attack. So if you take the power of HTTP2 reset and you multiply it by 1 million of IoT devices and a botnet, it could be devastating to any entity, whether it be a country or a company, to have that much traffic being sent to your server. And a lot of the newbies within the hacking cybersecurity world, think that DDoS is something of the past. Right? That is, we're past that time when DDoS attacks were really important. But the truth of the matter is that we may be entering into a new era of DDoS attacks because of a number of different developments in the industry, as well as all of these devices, these compromised IoT devices that can be used in an attack like this. If you were to take this type of attack and then connect it to a botnet of, say, 20,000 devices, the amount of traffic would just be overwhelming. It could overwhelm just about any server, or in that matter, any servers from any entity that's out there. So I think we're entering into a new era where DDoS attacks are going to be more and more important. And that's why I want to talk about those on your show, because I think it's being underestimated at how important it can be. It could be used, DDoS attacks can be used for extortion against a company, and it has been, right? We've seen cases where, and at Hackers Arise, we've had this done to us as well. And a couple of years ago, we had a hacker group come to us and said, unless you pay us this amount, we're going to DDoS your site. And I knew that we had good DDoS protection in place, so I wasn't worried too much about it. But they went ahead and attacked us anyways, and we didn't pay them. Of course, but we were down for maybe a half an hour or so, maybe 40 minutes, and we were able to recover very quickly. But this is a common attack vector, a way of making money, is when you have a group who has a botnet, okay, and they could rent a botnet. They don't have to own it. They can rent a botnet and then use it to go ahead and attack you and say, unless you pay us, we're not going to allow your site back on the web. And this is a common attack, and of course, in the cyber warfare field, we've seen it used a number of times. Russia has used it against a number of countries, probably most famously in 2008 before they attacked Georgia, which some people mark as the beginning of cyber warfare in 2008, where Russia invaded Georgia, the nation of Georgia, and they occupied, very similar to what they're doing in Ukraine, they occupied South Ossetia. And before they did that, they basically did a DDoS attack against Georgia so that Georgia couldn't respond. There was no communication. So the whole country basically was knocked out from a DDoS attack. And so the military and the government couldn't properly respond to the attack. So it's not just a commercial attack, but it can be actually a type of cyber warfare as well.
Right. And, it's so true what you say. What happened in COVID, of course, we were all pushed. All the applications started to move out from the traditional data centers, move to the private cloud, public cloud, multi-cloud, right? So we were all pushed online. And I think you mentioned Russia. The main change, at least what we see in my company, that main change in the threat landscape started when the Russia-Ukraine war was triggered, as Russia itself was attacked by a lot of pro-Ukraine supporters and started also to leak tools and methodologies to different proxies to use on its behalf. And it became like a nation-state cyber war, right? It's not only anymore Russia or Ukraine or Israel and Hamas. It's coming the East against the West. And we do see a shift between network level attack into application level attacks that are more sophisticated than before and cause more harm. Because DDoS is a great tool, definitely for extortion and financial gains, as you mentioned. It's very common. But also it's a geopolitical cyber weapon that can take countries or significant organizations or symbol of a country, right? To humiliate,
Exactly.
or to show some strength. We saw it against Japan, saw it against Australia, New Zealand, US. 50 US airports were down as a number of 50 states in the US by Killnet. That is using mainly DDoS attacks, Layer 7 DDoS attacks. So
Yes.
I agree with you. Maybe we are at the beginning of a new era.
I think we are at the beginning of a new era. And as you say, Killnet, if your viewers aren't familiar with it, is a Russia-aligned group that primarily does DDoS attacks. That's their specialty, and they go around and DDoS various organizations, countries, companies, and they have shown some capability of being able to inflict a significant amount of harm against some companies and countries. On the other hand, at the beginning of the Ukraine-Russia war, the coalition of hackers around the world all got together and basically DDoSed all the major institutional and governmental agencies in Russia that make it more difficult for them to actually communicate and respond. And that lasted for a significant period of time. Rostelecom, the Russian telecom company, said it was the largest DDoS attack they had ever seen. It was twice the size of the largest DDoS attack they had ever seen in their history.
Indeed, it's significant. So I think with that said, for everyone here, if you are interested to see more of what we have shown, this is maybe one variant. Of course, DOS and DDoS attacks today are much more sophisticated, coming in different form. It can come as volumetric, it can come as low and slow and more sophisticated. It can definitely exploit vulnerabilities in protocols. So if you are interested to learn more about that, if you are interested to learn more about hacking, please leave your comments in this video description. So Occupy the Web and I will read it and be able to address. Definitely, we are planning more and more videos. If you want to learn more about hacking, or you want to become a master hacker, maybe as Occupy the Web, check his community page, Hacker Arise. There are many variety of courses, from fundamental to more advanced, always at the top, and always also not only theoretical but also practical, which key. I think this is one of the differentiation what I like in Hacker Arise. Anything to add, Occupy the Web?
No, I just want to emphasize to your viewers that they should pay attention to these DDoS techniques. And depending upon what side of the attack they're on, this could become a really important vector of cybersecurity attacks in the very near future, if it isn't already. And what I'd like to do is cover in the future various other variations on DDoS attacks to kind of help your viewer understand what's actually going on and how DDoSs are evolving from something that was often be considered a script kiddie activity into much more sophisticated and dangerous attacks that we all need to be conscious of.
Right, it's very important. So with that said, and sake of time, thank you very much, Occupy the Web. Thank you for everyone that was watching. Keep watching us. Let us know what you like to see in the channel, what you like to hear from Occupy the Web. And until then, see you.